I'm going to cover a wide variety of concepts that we've covered in this trimester, kind of per your guys' requests. So I'm going to start with the earliest thing, which is area. We'll just jump right in. I'm going to be looking at page 390. I'm looking at number 29. And then I'm going to go to the test from chapter 9, and I'm going to do this one here. So number 29, we are giving a square with a equilateral triangle in the middle of it. And we're asked to find all this shaded area. So W, H, E, A, T. So again, we're trying to find the shaded area, so all we're going to do is we're going to find the area of the whole square, and then we're going to subtract out the area of the triangle. And that's going to give us all this stuff here. So we're told this is a square, and this is a triangle, so for the square, WHEA, it's going to equal 10 times 10, because area, you're just, for a square or a rectangle, you're going to take the length and multiply by the height. And so that's going to be 100. And then the triangle WTA is going to be the base times the height divided by 2. So the way we're going to find the height here, there are a few different ways. We'll look back at some of the theorems that we've covered. Not that one. We could use Pythagorean's theorem to do this. Basically, if we were going to use Pythagorean's theorem, we'd cut this in half. This is 5, and this is 10, which means that this is going to be 5 squared, 25. Let's do this. Yeah, okay, we're going to use Pythagorean's theorem. So we know that taking the altitude, it's going to be cutting this in half, so we're left with 5 squared plus b squared is going to equal 10 squared. So 25 plus b squared equals 100. So b equals 100 minus 25 square rooted, which is square root of 75. And that is just going to be 5 square root of 3. So we have another theorem that we've covered in the right triangle section, or right triangle chapter, stating this exact thing, that if you have the hypotenuse twice as long as the leg, that the longer leg is going to be 5 square root of 3. So we found our height. So again, we were finding our height here. So 10 times 5 square root of 3 times 1/2. And this is going to be 25 square root of 3. So our area for the shaded part is just going to be 100 minus 25 square root 3. Which is going to equal... Actually, I'm going to double check this really quick. Always good to double check. 3, 25, 5, okay. 5, 2, 25 square root of 3, so 100 minus 25 square root of 3 You're going to give us something like 56.7. change this to approximately. That would be our answer for that one. If we're looking at chapter 9, this is a little more tricky, and I'll explain why in a sec here. So we are given, what is that? This shape. Something like this. This is shaded, this is shaded. We're asked to find the shaded area given 5, 3, and 2. So what we're going to do here is, first we need to know if this is a square. This figure consists of 2 overlapping squares. Yeah, so this is a square, and this, even though it's not drawn properly, is a square. So the first square, the big one, we're going to look at it. The base here is 5 plus 3, which is 8, which means all of these sides are 8. So this area is 64. And then the little square, this one here, is 3 plus 2, which is 5, so 5 times 5. So the area for that one is 25. But we're trying to look at just this spot here, right? We're trying to take that spot out. So we have to, we're going to actually split this one into 2 rectangles. So we have, let's do it here. We have 3 by 5, which is going to be 15. And we have 2 by 5, which is going to be 10. So we're going to add 10 to this area, which is this here. And we're going to take out 15, which is this area here. So again, we're trying to find the shaded area. And then we're left with 74 minus 15. 74 minus 15, which is going to be 59, I think. 74 minus 15. Yep. Okay. Good. So we did that one right. I think. I'm trying to think. Let me just double check it really quick. What is this? Chapter 9. Chapter 9. Yep. Okay, good. 59 is our answer down here. It's correct. Okay, next we are going to talk about... Sorry, this is a bunch of different work. We are going to talk about... already did area. What is this? Sine, cosine, and tangent. So tangent is the ratio of opposite over adjacent. Sine is opposite over hypotenuse. And cosine is adjacent over hypotenuse. So the way I remember this is so you have the ratio, it's like sine opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. SOHCAHTOA. I'll hyphenate it for you there. So when we're trying to solve using these ratios, let's say we have a triangle. let's say, so we have an angle and two sides. So all we need is 2 out of these 3 things to solve for one of them. So if we're given this angle on this side, we can use tangent equals opposite over adjacent to find x. Same thing if we know these two, we can find this angle. Also, if we know these two, we can find this side. So I'm going to look at some of these problems. Let's do, I'll do 21 and I'll do 25. So 21, something like this. We're told this angle is 70, this leg is 10, and this leg is x. So we're trying to find x in this situation. So we're going to do tangent of 70 equals opposite, which is x, over adjacent, which is 10. And so now I'm just going to use algebra to solve for this. So 10, I'm going to multiply 10 to both sides, cancel them out. So now I'm left with 10 times tangent of 70 equals x. So if you'll be given this for the final, page 411. So I'm going to look for tangent. Well, first I'm going to find 70 degrees, and I'm going to look for tangent is the third column, so 2.747. So 10 times 2.747 is going to equal 27.47. And obviously this side is longer, which makes sense that x is going to be bigger than 10. So x equals 27.47. Now we'll look at number 25, which is a triangle that sort of looks like this. X, 11, and 4. So this time we're given both legs, and we're supposed to find x. So this is pretty simple. So tangent of x equals opposite, which is 4, because we're looking opposite of the angle, 4 over 11, which is going to be a little below 0.5. So tangent of x will equal 0.363636. Let's just check that with here what angle that is. So I'm going to look in the tangent line, and I'm going to look for 0.36. So this is 0.364, which if I round up, the next digit is going to be a 4 if I get rid of this repetend. So 3.64 is 20 degrees, so x equals 20 degrees. Which makes sense because it is an acute angle here. Now we're going to look at some cosine and sine examples. So I'm looking at, I'm going to look at 23, and I'm basically going to use the same shape and same lengths, and I'm just going to use cosine and sine to solve. So the first time we're looking at 23, and I don't know whether to use sine or cosine. They don't tell me what to use. So I'm going to look at SOHCAHTOA. I'm going to see that they gave me 10 as the hypotenuse, right? So it can't be tangent. We're not going to use tangent. And they gave us the opposite of the angle, right? Which means it's going to be this one. So I'm going to use sine of 32, which is the angle, is equal to opposite over hypotenuse, so x over 10. So again, I'm just going to use some algebra. I'm going to multiply both sides by 10. So I have 10 times sine of 32 equals x. So I'm going to look at page 411. I'm going to look for degree 32, and the sine is 0.53. So 0.53, 10 times 0.530 equals 5.3. So this side over here is 5.3. So now we are going to we're going to solve for y here now. So I'm trying to find y, which is adjacent, so I'm going to use cosine, right? I'll just redraw this here. Y, 32, 10. So, toa. Again, they gave me a hypotenuse, so it can't be tangent. And they gave me adjacent, not opposite, so it's going to be cosine this time. So, I'm going to do cosine of 32, which equals adjacent, which is y, over hypotenuse, which is 10, and do algebra. Cosine 32 equals y, which is going to equal, come here, go to 32 again, 0.848 times 10 is going to be 8.48. So I did that one a little quicker because it's the same algebra that I use here. I just explained why I used cosine. Now I'm going to change it up a little bit here. So we were given some simple algebraic problems. This time I'm going to take number 26 from your book. 26 here. I'm going to do the same thing. So we're given this triangle with angle 70, leg 4, hypotenuse x. So, toa. Again, they gave me a hypotenuse, so it's not tangent. And they gave me adjacent, which means it's going to be this one. So I'm going to do cosine of 70 equals adjacent, which is 4, over hypotenuse, which is x. The easiest way to do this, to solve for this algebraically, is we're actually going to multiply x to both sides, which seems a little counterintuitive. So we're x times cosine of 70 equals 4. And then we're actually going to divide both sides by cosine of 70. Which is leaving me with x equals 4 over cosine of 70. We're going to go to page 411 again. Going to find 70, and I'm using cosine. So cosine of 70 is 0.342. So x equals 4 over 0.342. I can just plug that into my calculator. 4 divided by 0.342 is going to be equal to 11.7 if I'm rounding to the 10th place. Which makes sense because it's obviously longer than 4. So that is kind of how you do those. In terms of using them in a proof, so we'll just look at the practice test example. So we're looking at 7, write a complete proof for this, which is ABC is a right triangle, ABC is a right triangle, which is given. And we are trying to prove AC sine A equals AB tangent A. So the way we're going to go about this, again, is we're trying to see, we're looking ahead towards the goal. We're starting here. This is the starting line. This is the finish line. We're going to take this as far as we can in the direction of this, basically. So you see that we're using sine and tangent. And we're dealing with a right triangle, so we're going to use that to some extent. So we're going to start with the given. Triangle ABC is right triangle, which is given. And with this, I know that sine of A is going to equal opposite over hypotenuse, so BC over AB. And I'm just going to say definition of sine. And I know tangent, I'm going to use tangent of A. Tangent of A equals opposite, oops, sorry, this is the BC over AC. Alright, because this is the hypotenuse. Opposite over adjacent, so this one's BC over AB. So definition of sine. So from here, I'm going to look and I'm going to see that both of these share BC, right? And I know BC equals BC. So what I'm going to do is I'm going to get BC all by itself. I'm going to do that by multiplying this by AC on both sides and this by AB on both sides. So AC sine A equals BC, and AB tangent of A equals BC. I'm just going to say multiplication. It's not going to fit, but multiplication. I know BC equals itself. I can include this if I want. BC equals BC. We can say reflexive. And therefore, AC sine A equals AB tangent A using substitution, which indeed is my proof here. And so we are good to go. So it's basically a 5-step process. If you take this out, you don't really need this step, but I like to include it just to make it more complete.